Talking about the next paragraph, it says that let the differential equation of the curve y equal to fx is given by dy by dx equals e power x plus 1 minus y cos x upon sin x. The curve y equal to fx passes through the point pi by 2 comma pi by 2 plus e raised to power pi by 2. Then we have to consider the function gx equal to fx into sin x. So first of all, let us evaluate fx and then we'll talk about gx. So dy by dx is equal to e power x plus 1 upon sin x minus y cos x upon sin x. So it is a linear differential equation, clearly visible. Dy by dx plus y cot x is equal to e raised to the power x plus 1 by sin x. So the integrating factor of this particular differential equation is e raised to the power integral p dx. Integral p dx is integral cot x dx. So that is e raised to power ln sin x, and that is ultimately sin x. So integrating factor is sin x only. What is the solution? Y into the integrating factor is equal to integral of q. Q is e raised to power x plus 1 upon sin x. Multiplied by sin x, it will become e raised to power x plus 1 dx plus c. So y sin x is equal to e raised to the power x plus c, from the given condition that the curve passes through point pi by 2 comma pi by 2 plus e raised to power pi by 2. We can easily see that c is coming out to be 0. So c comes out to be 0. We have the function fx as e raised to the power x plus x upon sin x. And what is gx ultimately? Gx is fx into sin x. So that is even simpler. That is only e raised to the power x plus x. Talking about question number 53, gx is an increasing function in its domain. So let us find g dash x. It is e raised to power x plus 1. Definitely increasing function. E raised to power x is a non-negative function. Plus 1, obviously g dash x is strictly positive everywhere. So gx is an increasing function in its domain. Gx passes through the point 0 comma 2. So what is g0? It is e raised to power 0 plus 0. So that is 1. So B option is wrong. Gx is equal to x has exactly one solution. Gx is equal to x does not have any solution. So let us plot the graphs. E raised to power x plus x. So this is y equal to x. We have to keep in mind that e power x and x don't have any solution. So when x is positive, e power x is obviously dominating function. The graph will be very far away from the y equal to x line. And when x is negative, e power x take very small values, then x will become dominating. So it will be something like this. But yes, definitely it is never going to have any common solution with y equal to x. So no solution. No solution means C is wrong, D is correct. Final answer of the question number 53, AD. Let us move on to 54. Now students, area bounded by the curves y equal to gx, y equal to x, and the y-axis and the line x equals 1. So gx is e power x plus x. For the area bounded, let us draw the curves once again. The graph of gx will be something like this, going parallel to the line and then taking very increasing slope in the first quadrant. Okay, this is the x-axis, this is the y-axis. Fine. Y equal to x is a line already drawn in yellow. Y-axis is already drawn. X equal to 1 is a line parallel to y-axis. That means they are talking about this particular area. So area is simply integration 0 to 1 gx minus x dx. That will be e raised to power x from 0 to 1 dx, and that will be e minus 1. So e minus 1 is rational, no way, because e is irrational. Greater than 1, true, e has approximate value 2.71. Greater than 2, wrong, it is 1.71 exactly. Approximately, it is 1.71 approximately. E plus 1, wrong. So only answer correct for question number 54 is option number B, Bombay. Okay, let us move on to the next section, which contains match the column type questions. Let us move on to question number 55. Question number 55 says that if Lagrange's mean value theorem is applicable to y equal to fx on set A, then set A can be. Students, fx came out to be equal to e power x plus x upon sin x. At all the points where sin x is going to be 0, fx is going to lose its. So we have fx being discontinuous at all the points where denominator goes 0, so at x equal to 0 and at x equal to n pi, where n is an integer. Okay, we have to carefully look at the intervals. It is applicable on set A. So option number A is wrong because 0 lies in this interval. Option number B is wrong because pi lies in this interval. 1 to 2 is definitely correct. 16 by 5, this interval is 3.2 to 6. So 3.2 is definitely greater than pi. 6 is definitely less than 2 pi. So definitely it is a safe interval. Final answer of the question is option number C and D. Okay, let us move on to the next section that contains matrix type problems.